When you're working in more than one dimension, it's oftentimes useful to break a vector quantity up into its components that lie upon the coordinate system that you're using. What you see right here is a good example of this, where we have a vector A with some magnitude directed up and to the right, and our coordinate system that we're working in is our positive x direction to the right and our positive y direction pointed up. The key feature of this right here is that the vector A is not lying along either one of those coordinate systems. So what's going to be useful for us to do is break this vector A up into its components that lie only along each dimension. So a property of vectors is that the vector A can be represented as the sum of any other vectors. So let's break it up into its component just along the x-axis plus a component just along the y-axis, where we have right here the vector ax, just the component of A that lies along our x-axis, and here we have the vector ay, just the component that lies along the y-axis. The key feature here is they're starting at the same point and ending at the same point. So how can we solve for the magnitude of vector? Let's just start with vector ax. What is the magnitude of that in terms of what we were given? The vector A and the angle theta. Well, we can represent this as ax. The magnitude of the vector ax is going to be the vector A multiplied by some trigonometric term dealing with this angle theta. Well, this angle theta is adjacent to the ax vector. So think back to your SOHCAHTOA from your trig class. This is going to be the cosine of the angle theta. Now let's imagine that we want to solve for the magnitude of the vector ay, this side over here. Well, similarly, we're dealing with the side opposite the angle theta that we were given now. So again, think back to your trig class. Ay is going to be the magnitude of vector A multiplied by SOHCAHTOA sine of the angle theta. And that's how you can get the magnitude of ax and ay when you knew the hypotenuse of vector A. So finally, in terms of vector notation, how we can express what we just solved for is we could say that the vector A is equal to the vector ax plus the vector ay.